Thank you for joining me on this video. I'm going to be talking about soybean meal. Now, in the previous video that I recorded, I was talking about overall picture about feed ingredients that were coming from soy. And now this is first of several videos that is going to be talking specifically about these products. And we have a huge amount of data on soybean meal for livestock and poultry, and a very large amount also for aqua. And I'm not able to share all of that with you, but I'm just able to really share some highlights and, of course, give you sources and links through my QR codes that allow you then to go and read a lot more for yourselves. And hopefully that will help you to learn a lot more than I can share with you about soybean meal, since my time here with you is limited. In the first video, where I was just talking in general about feed ingredients from soy, I was focusing on production of soybeans. In this video, now we're going to be moving more specifically at looking at some of the same data sources, but looking at protein meal, soybean meal, and so on, and where the soybean meal is being used at the current time. So in this slide, we see here data from the USDA, and we're talking about protein meal. So this is about all of the plant meals that are being used. Most of them, whether we're talking about soy or rapeseed or sunflower or cottonseed or even palm kernel, are products that are basically used for very significant oil production for human consumption. And so at the top of our list by far is soybean. So estimation of soybean meal use for protein in animal feed consumption, about 254 million metric tons, and that amounts to about nearly 70% of all of the protein meal consumed. Now, I suppose some part of this may be going to some purified food products such as soy protein isolate and so on, but the majority of this is going to be going for animal feed. And so there we see soybean for above all. And let's go on now to the next slide. Here we're going to look now at soybean use in aquafeed. So first of all, at the very top of our list, we have 20.9 million metric tons being used for poultry feed, which is 62% of the total usage, whereas aquafeed is only at 0.2 million metric tons, or in other words, around 200,000 metric tons, about 0.5%, as we can see here. The fact is, soybean meal is not made for us in aquafeed. Soybean meal, every parameter, degree of cook, color, particle size, urease test, protein solubility index, all of these industrial tests are based on what is best for feeding poultry. So for us, we have to accept what is prepared for them, and we have to find ways to use it for ourselves. So I would say that some of the aqua feed laboratory standards have to be adjusted slightly from the standard methods that are being used in order to accommodate the physiology of the fish and the shrimp. For example, the urease test, it's a proxy for soy trypsin inhibitor. We don't necessarily have to accept the same values that the poultry industry seeks. Protein solubility index is a lot more important for us than it is for poultry, simply because the digestive systems of fish and shrimp work differently, especially considering that crustaceans like shrimp do not have an acidic stomach. And then also protein dispersibility values. And there are a few others, and I'll bring those up a little bit later. Let's look at soybean meal purchasing specifications. So these are the standards that are used by buyers and sellers in international trade in soy. The first thing we'll mention is I'm using data here from the United States, but Europe will have probably its own standards, and many countries will simply fall back on either the US standards or the European standards. So what I'm showing you here then is the standards from the USA. This is the grades and grade requirements for soybeans. So we have 4 grades, 1, 2, 3, and 4. We have moisture content. We've got bulk density. We have contamination, damage, foreign material. Soybeans are split. Soybeans of other colors. And then in terms of the foreign material here, it can be broken down into animal filth, so this is feces from rats, for example, castor beans, crotalaria seeds, glass stones, and so on. And if we're looking here then at the specifications for the, let's say, the substandard grades, here we can see on this side what those requirements are. And all of this is coming from this book, U.S. Soybean Export Council Quality Control Manual. I'll be showing you that in more detail in a moment. Although I'm giving you here the QR code, you can scan that and it will just automatically download to your device. Same document. These are the main specifications. So this would be for solvent extracted and dehulled soybean meal. So solvent extracted, this means it is with hulls. And that's this column right here. The main thing we can see is that the protein minimum is 44. So internationally, the specification for soy is minimum 44 and minimum 46, although typically it's more likely to be around 48. As you can see here, looking at the dehulled, it's between 47.5 and 49. Fat, of course, is not very different, but we do see some difference here in fiber because with the solvent extracted soybean meal containing the hulls will contribute a considerable amount of fiber. And then in some cases, some shipments may contain anti-caking agent. Soybean meal is notorious for keeping it in storage in multiple months in silos and so on, or even using it in a feed meal. If it sits a while, it tends to stick together with one another, with other pieces, and so then it doesn't flow. It plugs silos and bridging and all kinds of problems that are going on. And so you can add a small quantity of an anti-caking agent to help you overcome some of those problems. Analytical characteristics of common types of soy products. We're really only interested in this video in the soybean meal, but nevertheless, we see here the raw soy, full fat soy, and then our soybean meal. So protein is 42 to 50. That depends on whether the hulls have been removed or not. Compare that with full fat soy 33 to 37. The difference between these is really the fat content. So full fat soy hasn't had any of the fat removed, whereas the soybean meal has had the fat removed generally by solvent extraction. And then we also see here then fermented soy and enzyme treated soy. These two are these two here are quite similar kinds of products. And then I'm not going to really pay much attention at this moment to the SPC or the soy protein isolate. Some additional recommendations. So if you're in the business of making fish feed and you're going to negotiate with a seller to sell soybean meal to you, these are some other specifications that you can add on to your purchasing request, depending on how concerned you are, the nutritionist is about these. So we can ask for a minimum lysine content. We can actually ask for a digestible lysine. Although how relevant that is for aqua, simply because a test like this is probably optimized for poultry. We can specify ash content, acid insoluble ash, silica. So this is more or less related to whether there's any sand in the material or not. Protein solubility index and potassium hydroxide, we can basically ask for a minimum value. Then we have urease test, trypsin inhibitor content. Urease activity is something commonly done in feed mill laboratories, but the trypsin inhibitor tests are kind of complicated, and it's not really been turned into a any kind of a quick test. You may be able to do that with an NAR, but there's a lot of time and effort and also money involved in doing that. And then we're going to be looking at screens. Are we going to be not wanting to have any dust? Or do we want to have any foreign material like not necessarily stones, but we might see bits and pieces of the bush that the soy came from? And what about the color? We want light tan to light brown. Then we want odor. So we want a fresh odor, what I would call a beanie odor, characteristic of soybean meal. Not musty, not sour, and definitely not burned. And then we don't want any contaminants in there either. This is the full view here of this document that I've been referring to from these last few slides. USAC Quality Manual and Analysis for Soybean Products in the Feed Industry. So they cover everything from soybeans through all of the various kinds of soy products, including feed ingredients for dairy and so on, the things that we don't consider for use in aqua because there's too much indigestible fiber material and so on. I've taken the liberty to not give you the entire table of contents. You can see that this starts at number 8, section 8, and then we're basically looking here at the tests that are found in this book that are related to the laboratory analysis for soybean meal quality. And in each case, the tests that are commonly used are provided here, step by step, sample preparation, reagents, technique, all kinds of things, timings, filtration, it's all in there. All of the methods here are provided mostly from the American Oil Chemist Society, the AOCS. These are particularly relevant to any kind of a product coming from oil seeds, including the meals and also the oil. And then we also have a very similar organization, the AOAC, the Association of Analytical Chemists, but they're covering every other kind of a thing from industrial processes through chemicals and industrial products, rubber, all kinds of things. But all of the same kinds of standard tests that are used for feeds are in there as well. All of this then is based here on the American National Oil Processors Association trading rules. So those previous few slides showing you what the specifications were for buying and selling soy are basically coming from the NOPA trading rules. This is another useful book written by this PhD veterinarian consultant, Mr. Kohlmeier. Soybean meal, and full-fat soya quality control handbook. Curiously, I cannot find this in Google Scholar, but when I just searched for it in my browser, it showed up at this link down here. And if you click on this QR code, that will actually just download this to you. He has taken a slightly different approach, maybe a little bit more international. He's emphasis on the GAFTA rules. So the GAFTA rules are the generalized trading rules that are used for international trade more than any other rules. And in here, he offers all kinds of template letters that you can use. You can customize them for your own use, basically leaving spaces for names and so on, giving you the specifications that are typically accepted for the soy products. And he's giving you, in terms of US standards and EU standards, and then also he's using the same AOCS standards. He's providing you also with all of the analytical methods. What do I look for with soybean meal when I'm interested in buying it? Physical characteristics, I want a uniform particle size, but minimal fines. I might do a sieve test to see if there's any fines that are going to be dropping out. I want minimum woody stuff. Normally in soybean meal, and the beginning photograph that I showed you was actually this same photograph here. And for me, if you can recall, that was actually a very clean, very nice looking sample of soy. If it contained any woody material, quite often you will see little green specks. Like, for example, that might be just like a tiny little piece of a soybean bush or something like that. We want a yellow to light tan color, not brown. I have a slide coming up that shows you exactly what I mean by this. And then if you are interested in controlling color and things like soybean color, if you have it at 30% of the feed formulation, will actually impact the color of your finished feeds. And so we do need to have some way to assess the uniformity and consistency of the color. And we do that through what we call the Hunter LAB scores. The numbers that are given to us from this paper that I cite there, that for the best soybean meal should have a Hunter Lab score in the range of 58 to 65. In terms of chemical standards, the feed, of course, needs to meet the nutrient specs according to the certificate of analysis provided by the seller. Quite often that would have come from an independent lab like SGS. And then we need to assess the supplier coefficient of variation, the CV, as a percent. And I do that on protein, fiber, ash. I accumulate that data and I use it to assess and rank my suppliers. The suppliers that have the lowest CV, like the most consistent, similar uniform protein levels without much variation, or maybe I will look at those and say, well, this guy has a low CV, I want to buy more from him. That's what I'll tell purchasing. If I am not happy, the protein content is bouncing up and down more than I'd like, I might suggest to purchasing, really don't buy too much from these people unless we really have to. Why? Because when we're formulating feed, we do not know what ton of soy that came into the warehouse is going to be into the feed. And so what that does is it causes the protein level of the finished products to also not be uniform, especially when we're dealing with soy at quite high percentages of the formula, say 25 to 30%. Could be quite common in a feed for like a carp or tilapia, maybe even higher levels than that. We want to have low fiber. So crude fiber is what most people test. I've actually advocate that we should be testing total dietary fiber, which is a little bit more inclusive of some of the other types of fiber that do impact digestion. I want to see values typically for a high-pro soybean meal, say 47, 48%. I want to see fiber levels in the range of 3.5 to 4. I do have a problem here with Indian soybean meal because Indian soybean meal for the same protein level will often have a fiber content of 6 or so. And I am concerned about fiber because there's been a professor from University of Guelph in Canada, Dr. Trevor Smith, who has done a lot of work on the presence of mycotoxins in soybean meal. And I actually heard him give a talk here in Thailand where he said that he was able to correlate the performance of swine with the amount of hulls that were present in the soybean meal, because this soybean meal hulls is the substrate for the mycotoxins. He was primarily talking about the fumonisin. That could also include others like the ochratoxins and so on. We'll talk a little bit about mycotoxins later on here. Then the standard urease enzyme test value of soybean processors is typically delta. That is from the start of the enzyme test to the end, that we're going to see a change in pH of less than or equal to 0.5 pH units. But for aquatic feeds, I don't have any problem having a delta of 0.05. Partly that is not acceptable for poultry, because for poultry that's considered to be overcooked. But for aqua, as I'll explain in a moment, it's not really too much of a concern. By comparison here, raw soybean has a delta pH greater than 2. And the reason I don't really care too much about the value I get from urease test is because when we're talking about feeds, especially extruded feeds, where our processing is very aggressive, we have high temperature, we have high pressure, we have high shear. Basically, none of these enzymes, whether we're talking urease or we're talking trypsin inhibitor, can really survive that process. They will all be denatured. And so I don't put a lot of faith in the urease enzyme test. Color, I did mention it a moment ago. This is acceptable. So this is a nice kind of a whitish color. The sample that I was showing you there earlier is probably looks more like this one. I don't want to see dark, and I don't want to see, especially don't want to see very dark like this. The reason is that the protein digestibility will be gone down considerably due to overcooking and damage to the protein. If we have an impact with the Maillard reaction, then available lysine can be very low. And the Maillard reaction also impacts some of the other amino acids that have ring structures in them, like histidine and phenylalanine. Also, arginine is impacted by the Maillard reaction. So we don't want to have a dark color. Let's look at nutritional value. I just might mention that this book here we're talking about is called Recent Trends for Enhancing the Diversity and Quality of Soybean Products. This is coming from an organization called Intech Open. They have 4 or 5 different books that are focusing specifically on soybeans and so on. They are all openly available. You can go to their website. In this case, if you click on this link, it will probably take you to the, not necessarily to the entire contents of this volume, but it might take you specifically to the page relating to this paper, which is one of the chapters in the book, Soybean as a Feed Ingredient for Livestock and Poultry by H.K. Day. In order to download the entire book or download the chapters, you normally would have to register with your email every single time, and then you can just download these documents. Many interesting papers here. So what I'm really focusing on now is the typical chemical analysis. So we have here, once again, comparison, and we have full-fat soy, soybean meal, soy protein concentrate, and isolate. One of the critical issues with us in aqua is the quantity of amino acids, particularly lysine, methionine, and cysteine, because these are low relative to fish meal and animal protein meals. Because of the protein content of the full-fat soy is only 37 due to that high fat content, the amino acids quantities are lower than in the soybean meal. And here we're looking at soybean meal 44 to say 49%. And so then I'm assuming that this is for the 43.9, and this one is for the 48.8. And then down below here we have urease activity, trypsin inhibitor quantities, some of the globular proteins, lectins, oligosaccharides, and saponins. These are some of the anti-nutritional factors that I'll be bringing up in a small amount later, but of course I covered it in much more detail in the first video about feed ingredients from soybeans. Here's another paper. This one, I believe, was also in the previous video on soybeans. Here, I'm specifically looking at, once again, the amino acids. So we have lysine. We have the lysine as a percentage of protein, and we have methionine and cysteine. So very often we look at methionine, and we know that cysteine and methionine are both sulfur containing amino acids. In some cases, supplying cysteine can replace the need for methionine. The cysteine is used. However, if cysteine is in deficiency, then methionine will be broken down and used instead, which we want to avoid. In this case, we're comparing D-hold. So this would be 40, 48, 46.5, and 49.6. versus non-D-hold. Because the holes are there, then of course the protein content is a little bit lower. And we see relatively minor differences between these different countries of origin. This is another paper, more recent, and here we're looking at influence of origin of the beans on protein quality and nutritive value. This is based on 389 soybean samples collected from 2007 to 2011. In this column, it's reported here as 5-year. So that's for those 5-year period there. Then from 2012, 30, 30, 30. So that's showing in this column right here. Once again, we see Argentina, Brazil, and USA. And then we have lysine, methionine, and methionine cysteine. Now, one thing that they've shown us here is probability. So they've done the testing. And so 3 stars tells us that it was significant less than 0.001%. So that's highly significant. And what that's telling us is that in most cases, the origin of the soy definitely has an impact on the amount of available lysine, methionine, and amino acid content, although it was kind of indicated in those previous couple of slides that I showed you. And then also the period of collection. So this is also significant for amino acids. I'm assuming period of collection means they're comparing this to this. And if it's significant, it suggests that breeding and activities related to crop science and maybe selective breeding and other genetic modifications that have been made has had some impact on the protein quality and overall quality. This one is a paper related to fish. So this is a comparison of amino acid profiles. And this one is actually in the beginning of a paper that's talking about a Brazilian fish, Colossoma macropomum. This is a herbivorous fish from the Amazon. The body shape and its coloration is very similar to the piranha. I've grown these in aquarium, and they love to eat vegetables. They just strip them overnight. So I've given you 2 QR codes. This QR code is for the direct source to this paper. If you have institutional access and you can see the paper, the real paper from the website through your subscription, then go to this one. If you're not don't have access, then use this QR code and it will take you to this. So this is a paper that I got through Sci-Hub, and it's actually just a photocopy of the paper, but it allows me to share this information for you. Notice over here the references are all coming from this reference number 4, and this is the place where all of that FAO information came from. It's actually a series of web pages. It's not available as a PDF document. It was a paper written some time ago by Dr. Albert Tacon, and it gives you long lists of the nutrients and amino acid profile of numerous ingredients. What I wanted really to highlight here was just this one right here. So we have herring. Herring is a fish meal commonly used in the Canadian Pacific. It's also used in some parts of the North Atlantic, although it might not be the major one. And then right beside it here we have soya. So I'm assuming this is soybean meal. And then in the green, I've got my lysine and I've got my methionine. So if we're looking at soya, even though typically soy is supposed to be, like other plants, low in lysine, it's actually relatively decent. It's certainly higher than in meat and bone meal, for example. But when we look at methionine, the amount of methionine that's in the soya is considerably less. What's that? 40% less. When we start pushing our soy content up in our feed formulations, then we can begin to run into issues with balancing our methionine properly. And while we have the cysteine, I did mention that cysteine can replace some of the methionine, but it cannot replace all of it. Another paper, this is by Lagos and Stein. Stein is a well-known U.S. nutritionist working with swine. So this is a fairly recent paper, Chemical Composition and Amino Acid Digestibility of Soybean Meal Produced in the United States, China, Argentina, Brazil, or India. The concentration of energy, the dry matter, nutrients, and once again, I'm going down here and I'm highlighting the lysine and the methionine. Here they do give us some of the non-starch polysaccharides, and also the trypsin inhibitor is also down here. I'm going to use some data a little bit later on that I've taken from one of these slides. Then, okay, so over this side we have the indispensable amino acids. This side is the dispensable amino acids. In terms of the lipid composition of soybean meal, full-fat soy, and soy protein concentrate and soybean meal have very low levels of lipids. In the case here, you see 1.2% for soybean meal. That sometimes is on the high side. Very often, from a modern factory, you could actually find a value below 1. And then soy protein concentrate is very, very low. Well, the full-fat soy has quite a lot. So actually, in fact, in terms of, the contribution of lipids from soybean meal in the feed formulation, it's always going to be a minor content and not necessarily of concern. Nevertheless, when we look at the fatty acid profile, the outstanding characteristic of soybean oil is the presence of more than 50% content of linoleic acid. Now, we do need in omnivorous and herbivorous fish, we oftentimes see that there is a nutrient requirement, essential fatty acid requirement for linoleic and linolenic, whereas there might not be one for the long-chain polyunsaturated fatty acids like the EPA and the DHA. And that's partly because some of these animals, they don't normally, like herbivorous fish, freshwater fish, they don't normally encounter a lot of DHA in their environment. But if they're fed the linoleic and the linolenic, they can actually manufacture their own EPA and DHA as needed. Same authors as previous, but now we're looking at the minerals in the soybean. And I'm really here looking at the phosphorus content and the total phytate. So phytate, very often in seeds, this is the main storage form of storing minerals in seeds. As phytic acid, if it's phytin, that's a very common form that's found. It's primarily with calcium and magnesium salts. And then we have the non-phytate phosphorus here with the red arrow. So this is the part, without going and using a phytase enzyme, this is really the part that is going to be bioavailable to the fish. The phytate-bound phosphorus will not be available. Then we have the macro minerals and some of the other micro minerals or trace minerals. This paper, Chemical Composition and Protein Quality Comparisons of Soybeans and Soybean Meals from 5 leading soybean producing countries. They did something interesting here. So they collected samples from these 5 countries and they tested them in those countries and they collected that information. Then they brought samples of all of those different soys back to one laboratory in the United States. They took those soybeans and they prepared soybean meal from those soys in one location. They might have done it, like, for example, in a pilot scale lab in a university or something like that. But the fact that they were all made in the same facility, even though the source of the soybeans was all of these different countries, gives us an interesting way to compare. So here we see, once again, coming from all these different origins, variability a little bit in the phosphorus content. Then we go down here, we see the other macro minerals and the trace minerals. A few slides now on soybean meal digestibility. It's surprisingly hard to find a lot of information, even in sources like Google Scholar, and I will just be highlighting a few species here in just 3 or 4 slides. But this paper by Delbert Gatland from Texas A&M University is on the use of soybean meal in the diets of omnivorous freshwater fish. So this was published, I believe, by the American Soybean Association, and then it can be also found in several different formats. In this case, he's giving us information about multiple species: channel catfish, Nile tilapia, blue tilapia, hybrid tilapia, which are the red tilapia, common carp, and silver perch. We have soybean meal solvent extracted with hulls, so that would be low pro, and then we have soybean meal without hulls, that's high pro, and then we have full fat and soybean whole expeller. So this is essentially another kind of a full fat product, but it was made from whole soybeans and it was not dehulled soybeans. What we get then is the apparent digestibility of these different species. We see here for dry matter, apparent digestibility of protein, lipid, and carbohydrate, and also for energy. It's hard to find information about fish that are not omnivorous freshwater species, but here we have a paper. We're looking at the soybean meal digestibility in haddock. So this is a cold water North Pacific marine species. Looking at the table, we have apparent digestibility coefficients. So A is the contribution to the test diet from the basal diet. So this is basically everything but the soy. And then B is the contribution coming from the soy. So for example, as the soy level goes up, we see that the percent coming from the soy, the value is increasing against this, which is the uh, reduction of everything else outside of the soy. And then over here we have the apparent digestibility coefficient from a couple of papers. This is from Forster from 1999, and this one was from Cho et al. From 1982. So we can see as the apparent digestibility coefficients seems to be for organic matter. They're in the vicinity of, let's say, the 80s, although actually some of these numbers seem to be quite low. And some of the other researchers have found quite a bit higher value. So you can go and look at that paper and decide how much you want to put your belief in it. The thing is, whenever we're doing digestibility studies, there are different tanks, different feces collection methods, different analytical methods, different ways of feeding the fish. And all of those contribute to a fair amount of variability, and sometimes it's quite difficult to compare laboratories, although within a single laboratory, results can be, relatively consistent across from one species to another. But comparing labs is sometimes quite difficult. So you'd have to go and look at the paper and see what they did and how they did it, whether you can accept their results or not. Here's another paper. This one is on Atlantic cod. So this is a cold water North Atlantic species. And in this case, what we're looking at is they've tested a bunch of ingredients. So they have a reference diet here. They've got a couple of fish meals they've tested, some crustacean meals, and we're interested right down here. So here we have soybean meal, soy protein concentrate, and soy protein isolate. And we have the apparent digestibility coefficient of protein, of energy, and digestible energy. So they're reporting that the protein apparent digestibility of soybean protein is quite high, 92%, and then due to the reduction of the fiber component and the high protein level, then soy protein concentrate and soy protein isolate are even better. Energy digestibility is quite high for the soy, is 88%. That's not too bad. Although, as we talked about before, the actual quantity of oil that's coming out of the soy is actually quite low compared with other ingredients like fish meal, for example. Another paper, this one also coming from Europe with the European sea bass. And in this case, we have these codes over here. So SE is standard solvent extracted soybean meal, ME is mechanically extracted, and ET is enzyme treated. And that's what we see here. So here we see solvent extracted, mechanically extracted, and enzyme treated right here. This is the basis of the diet. So soybean meal inclusion in the different feeds at this level. And then here we have a combination of two. So this is the diet composition. And then we can see down here that as we increase the soy or change a different kind of a soy product, that the apparent digestibility coefficient of the, let's say, extracted soybean protein is very good, nearly 95%. The lipid is very digestible, although the quantity is small, as we've talked about, and energy is quite low. And then the digestible protein, and this is in terms of grams of kilogram of dry matter. So have a look at those numbers. Coming back to a freshwater species, common carp, Cyprinus carpio, from 1997. Very simple table right here, looking at soybean meal, fish meal, and poultry meal. Protein digestibility of the soy they found to be somewhat low, around 70%, where the fish meal was 84%, and energy digestibility was around 75%, giving us then, in terms of kilojoules per gram, lower than the fish meal. Well, energy level of fish meal is definitely going to be higher. These people actually have written two papers. This is the second one. There was another paper just looking at apparent digestibility of the ingredients and of various ingredients, and this one was looking at specifically protein sources. So if you search for this one, you should be able to find the other one as well. Here's one with rainbow trout and coho salmon. Coho salmon is a North Pacific salmon, also grown and farmed in Chile. This was done by Dr. Sugiura. He's a professor in Japan. I would consider him to be the world's leading expert on phosphorus nutrition in fish. He's published many, many, many papers. So in this paper, then he was looking at the apparent digestibility of protein in the feed, and then also interested in minerals, particularly phosphorus. So we see two species, the coho salmon here, and the rainbow trout, and we're focusing particularly, well, we've got the fish meals up at the top here, protein digestibility in the vicinity of 94.5 to 97, whereas the soy is 96.4. These people, Dr. Ron Hardy, uh, and so on, these people are well qualified to do digestibility studies. They've done lots and lots of experience. So these numbers, I think, are fairly reliable, but once again, go and check out how they did it to see what's going on. Now, when we compare the soy of the coho salmon and the rainbow trout, it seems that the coho salmon is a fish that adapts quite well to soybean meal, which is almost the opposite of what we see with either the larger Pacific salmon, the Chinook salmon, or what some people call the king salmon, or we compare it with Atlantic salmon from the Atlantic Ocean. Now here we're focusing on phosphorus by the same authors. And the way that we understand this is absorption, so they're using a spectrophotometric method. This is our estimation of the available phosphorus in the diet, and this is the estimate of the available phosphorus in the ingredient. So in terms of the soybean meal, they're saying with coho salmon, it's only around 28% available phosphorus, and in the rainbow trout, it's only around 22% available phosphorus. The rest, of course, being in phytic acid and biologically unavailable unless we use a phytase enzyme to liberate more of it. Here's a paper from Brazil. The Dourado is a salmonid. I don't have a picture of it, but you can find one very easily on the internet. This paper has an abstract in Portuguese since it's from Brazil, but the paper itself is in English. So we have the basis of their diets. So we see the ingredients that they used and here, and so we have fish meal, meat and bone meal is that one is spray dried blood meal, and poultry byproduct meal, corn gluten meal, soybean meal. So this is really the one we want right here, soybean meal. And they're giving us then the energy digestibility and the protein digestibility. So in terms of the soy, they're showing us is about nearly 95%. And over here, then we have soy, and we have apparent amino acid digestibility of the essential and non-essential amino acids. Here's another fish from Brazil. This one I do not know. It's in any case, you can look it up and see what it looks like. It's not too large a fish. It's probably not more than about say 40 centimeters long or so. We have the apparent digestibility coefficients and digestible values of energy and crude protein of the tested ingredients. Soybean meal is here, and it's about 89% or so. That's of the gross energy. And then for the protein, they're showing us is only 68% or so. With the digestible protein, they're estimating at around 30%. So that's 304 grams per kilo. So about 30% is the digestible protein. Going back to this paper by Gatlin, now we're going to look at, rather than just the main nutrients, we're looking now at the essential amino acids, and we have the different kinds of soy. So soybean meal, solvent extracted, with hulls, without hulls, and then we have dehulled full fat, and we have full fat, but with hulls because they extruded the full soybean. So you see there that amino acid digestibilities in general are quite high, in above the 90s. I myself, with my PhD research, found that amino acid availability, digestibility was actually higher than protein digestibility, indicating that not all amino acids are uniformly high in their availability. One of the key things, and I've mentioned it several times here, is that we have low methionine, and also sometimes, depending on our feed composition, we might also have some issues with low lysine. What these authors are showing us is, you see their diets up here. So they have a positive control. This is a high protein diet with a 20%, or high fish meal diet with 20% soybean meal. And these ones are basically reversed. So they have 42% soybean meal and low fish meal. What's really interesting is if we look at these charts. So we have, in this case, weight gain in terms of grams of gain, and then we have protein gain down here. We have then methionine plus cysteine inclusion level, and as we get in excess of about 11.5 grams per kilogram of diet, or around 1.15%, then we see that we're more or less reaching the saturation level. Including more than that doesn't really improve the growth rate of the fish. Anti-nutritional factors, we're just going to look very briefly here, something specific about soybean meal itself. You've seen that one already. Why are we so concerned about anti-nutritional factors? Well, the fact is that they're called anti-nutritional factors because they have an impact on either digestion or they have an impact on metabolism. And the more we put in the feed, the poorer the feed intake might be, the poorer the feed performance might be, poorer growth, and so on. This is a paper from Europe looking at the nutritive value of 4 soybean products for Atlantic salmon. Keep in mind that soybean meal itself is not a preferred ingredient for Atlantic salmon. They are sensitive to it. So what we see then, we've got 4 products here in our highlights. So we have soybean meal 50%. We have full fat soybean. We have soybean meal 44, so that's with hulls. And then we have soybean concentrate. Not surprisingly, the dehulled high protein has a most significant weight gain as the quantities increase. And as we increase any of the other product, the full fat soy, extracted dehulled soy, and here in the low protein soybean with hulls, we see the lowest performance, meaning that the more we use, the worse the impact is on growth. And in that case, basically, we would say that there's really no point in using hulled because the growth rate drops off at even extremely low levels. Where for standard soybean meal, it seems like we can get somewhere in the 10 to 14%. Full fat soy is about the same before we start to see any negative effect on growth rates. Trypsin inhibitor. This is an interesting paper. Some of these researchers like Trond Storbakken and Asheld Krogadal, these are fish nutritionists. But this was a paper where they were putting soybean meal, 2 kinds, either normal cooked soybean meal, fat extracted, of course, or else they're using white flakes. In my first video, I mentioned that white flakes are solvent extracted, but they are not cooked. So they're white and they're raw. And what that does then is it means that the anti-nutritional factors like the soy trypsin inhibitor and the hemagglutinins, the lectins, are not denatured. In this case, the diets were then extruded. But these diets were not for fish. They were actually for mink, which is an important fur-bearing animal that's grown in Northern Europe to make fur for coats and hats and so on. So we have then a diet with 49% fish meal, no soy, diet with 30% fish meal and 25% standard soy, and then with 25% soybean white flakes, which are not roasted. And then they've added some wheat, fish oil, and vitamins, as you can see here. But note, when we look at these ingredients, they have determined that the trypsin inhibitor content of the white flakes is 37.5. The soybean meal is 8 milligrams per kilogram, and for some reason they do find some trypsin inhibitor in the fish meal, although that seems like quite strange. When we then go down here and look at the bottom, what I wanted to point out here was the impact of the extrusion. So of course, fish meal, let's just ignore that. We see in the standard soybean meal, when we extrude, we get a reduction of around 4 or 5 times reduction in the amount of trypsin inhibitor, and at about a 75% reduction in the extruded compared with unextruded white flakes. So that's why earlier I said I'm not particularly too concerned about a urease test value, because in our extrusion process and our preconditioning and so on, we're basically going to bring those levels down to 0 or down to such a low level that it's not really going to impact the digestion of the fish. The other issue that we have, and I've also kind of covered it a little bit here, is the presence of phytic acid and the impact it has on phosphorus availability. In this case, they're looking here at feedstuffs and the amount of phosphorus, phytate phosphorus, and phytase activity. So the reality is that phytic acid, or phytin, is the storage form for many minerals, primarily macrominerals, in the seeds before germination. And then when the seeds germinate, these seeds then produce their own phytase and begin to break down the phytic acid and release the minerals. And also the core, then we have a molecule of inositol, one of the water-soluble vitamins. We're then looking here at soybean 44, so that's with hulls, 48 without hulls, and then soybean 50, so a little bit better quality. The key thing here is that the amount of phytate, we don't want the phytate phosphorus, we want the non-phytate phosphorus. We see that the actual level of the available phosphorus in these samples is quite low. The reason it's important for us, I'm going to highlight a couple of slides here. This one is done with Mrgal carp, the Indian major carp. What they've done then, they've fed purified diets and artificially provided phytic acid, or phytate, as sodium phytate. And they included it at 0.5%, 1%, and 1.5%, compared with one without any added sodium phytate. We see a very significant increase in the feed conversion ratio. So obviously lower is better. And in this case, the feed in conversion is very, very poor, with a lot of added sodium phytate. So the thing is in the digestive system, even though carp are fish without a non-acidic stomach, the sodium phytate will dissociate, and then the phytic acid is available to begin to grab other things. It can grab proteins, it can grab amino acids, it can grab vitamins, and so on. Then when we're looking at the protein efficiency ratio, so focusing specifically on the impact on protein, we see that the protein efficiency is less than half at this 1.5% added sodium phytate level compared with the phytate-free diet. And I have one more slide. This is a paper where they fed sodium phytate to Atlantic salmon. They were feeding at levels of 1 gram per kilogram, 2.1, 4.7, 10, and 20.7 grams per kilogram. In order to accommodate the addition of the sodium phytate, the protein levels of these feeds were between about 51 and 54% protein. Now, I wanted to kind of just roughly estimate, if instead of using sodium phytate, we were to use soybean meal, high pro soybean meal instead, how much soybean meal would these numbers be equivalent to? This was from an earlier paper that I showed maybe 15 minutes ago or so. And I just simply picked the value here for Brazil, 1.57% phytic acid in the soy. So based on that Brazilian soy, I estimated how much soybean meal would need to be in the formulations to reach the same IP6 levels as those. This would be equivalent to a Brazilian soybean meal in kilograms per ton of feed. So to get 1 gram per kilo IP6, you would need 65 grams of soy, kilograms of soy, 134 kilograms of soy, 300 kilograms of soy, 635 kilograms of soy. And to reach 20, you would actually need more than 100%. Realistically, at these kind of protein levels, you would never be able to have about more than 300 kilograms of soy, because you simply would run out of room to put all of the protein that you needed into the feed. So this is impractical, and this one is basically impossible. And but nevertheless, as we increase the amount of phytic acid, or the sodium phytate, that the feed intake drops at the higher levels. The growth rate drops from about 109 here. Not so different, actually. They're all, according to this, are all at the same level. It's not a significant difference until we get at the very highest level. And of course, this is pretty much impossible. So then we have the feed conversion ratios and so on. So surprisingly, if we look at this, the salmon did not seem to be so totally impacted by the phytic acid. Now, if we look at the same paper, but in this case now we're focusing on the apparent digestibility of the nutrients rather than the growth performance results. We see nitrogen retention not really significantly different. Lipid did have some impact, but not sure why it started to go down there, and then it came up here and down here again. This might be a bit of an outlier. And the phosphorus retention is right there. So they've given us some regression equations which we could use for making estimations about the amounts that we would put in the feed. And then, of course, they're telling us over here whether they're significant or not significant. Moving on to another category of anti-nutritional factor, and that is mycotoxins in soybean meal. So this is data that's coming from researchers at Biomin. Biomin is one of the major suppliers worldwide of feed additives as mycotoxin binders. So they do have an interest in alerting the world about the presence of mycotoxins. Now, whether they're over-exaggerating, well, you can make that decision for yourself. But what I wanted to highlight here was that they're looking at soybean meals that they collected around the world, because their customers are worldwide, from 2009, 2010, 2011. And then they have North America, South America, Central Europe, and Southern Europe. Northern Europe I have on the next slide. Primarily, they're looking at DON, so deoxyvalenol, and fumonisin up here. This seemed to be the main one, although there are aflatoxins certainly in North America and in South America. Then down below we see North Asia, Southeast Asia, and South Asia. And once again, DON seems to be the one that everybody finds. But the thing is, with international trade, these mycotoxins used to be regional, but now with international trade and shipping, back and forth all around the world, using the same port facilities, same ships, same containers and everything. Now, basically, the mycotoxins have been distributed everywhere. Everybody encounters all of them now. The previous slide did not talk about Northern Europe. This one talks about Northern Europe. So this is looking at feedstuffs collected in Germany. 50 samples of soybean, 44 from Brazil, 3 from Argentina. Most of them, or half of them, were high-pro soybean meal, and they were obtained from European feed mills. So in many cases, we don't know who the feed mills were. It's not really important, but we also don't know much about the nature of these soybean meals. Then we have some codes here. So we have soybean meal, high pro soybean, soybean hulls, suspicious samples of high protein soybean meal. So these are samples that appeared to be at high risk of maybe color or maybe smell or something like that that alerted them. Then we see once again the zearalenone, the DON, the ochratoxin, and the aflatoxin B1. I think this one is quite interesting. If we look at this figure, comparison of zearalenone and aflatoxin B1 concentrations in soybean meal with and without hulls. And so this is without hulls, it's lower, and with hulls, it's higher. So this goes back to my original comment that I made, where I prefer to buy soybean meal with low fiber content because I want to avoid mycotoxin risk. And so I would always seek to buy the lowest fiber content that I could find at any given protein level. Carbohydrates, we're really here not talking about sugar, starch, or anything like that. We're really mostly interested in the non-starch polysaccharides, which are the true anti-nutritional factors. So this is probably from the first talk that I gave. We'll just skip over that. Here we have the insoluble NSP profile of Brazilian soybean meal. They have different varieties of soy that are grown in Brazil. So we have glucose, xylose, galactose, mannose, arabinose, uronic acids, and total non-starch polysaccharides. So that's the end of the main presentation, and I'm just going to finish off here now with some slides relating to resources that you can use to go and find out more about soybean meal. So first of all, this is a very interesting review called 100 Years of Soybean Meal. You can scan that QR code and download it. It was originally published in a trade journal, looks like a newspaper kind of a format in America called Feedstuffs. This is quite interesting because it talks about the very beginning of the soybean oil industry and then the original interest in using soybean meal as an animal feed ingredient, and then talks up until the present day about all of the changes and advancements and milestones that have been accomplished when we've had soybean meal around now for about 100 years. When we start talking about soybean meal quality, in addition to those two papers that I mentioned earlier, the main one from the United States Soybean Export Council and the other one from the private consultant, here we have two papers. These are both taken from Intech Open document books, so soybean meal quality and analytical techniques, and then also this is another paper, laboratory procedures for assessing quality of soybean meal. That's by some European researchers. In terms of looking at nutrition and so on, here we have the papers. I've kind of highlighted these in some of the tables that I've shown you. And then we have these two. So the first one there, 2020, and then on the right-hand side, 2022. Both from the journal Animal Feed Science and Technology. So chemical composition, protein quality indicators, and in vitro protein digestibility of commercial soybean meals from different origins, feeds, and poultry feed. So the fact that they do in vitro protein digestibility, they're probably having a system that kind of mimics the digestive enzymes of poultry. Then in the other paper, so chemical composition, protein quality, and nutritive value of commercial soybean meals produced from beans from different countries, a meta-analytical study. So this one is generic. It's not specific on any one animal or so on. And both of these papers are quite interesting. If you want to know more about soy trypsin inhibitor, these are 2 or 3 papers that you can find. I don't have the QR code for the bottom one, but it's easy to find and not. But I don't believe that it's free. In terms of the protein solubility index, which is one of the very important things that we need to know when we're looking for highly digestible soy for aquatic animals. The original people who did all of the work are these two on the left-hand side, Araba and Dale in Georgia, USA. They looked at underprocessing of soybean meal and then they looked at overprocessing of soybean meal, so undercooked and overcooked. And they were trying to find the range that they needed to recommend. We then have this paper by Parsons from University of Illinois in the state of Illinois, USA, and another one from the Americans here by Whittle and Araba, looking at sources of variability in the protein solubility assay. So these are all very good papers that you can read to understand how to use this test to the best of your capabilities in your own facility. The alternative, of course, to the potassium hydroxide test is the protein dispersibility index. And here's several papers that talk about it. I actually prefer this to the potassium hydroxide. The range of values is wider, and I would say that the protein dispersibility index actually gives you more, let's say, more resolution on differentiating good from better. Whereas the other one, it's kind of like bad, okay, good. Where this one it has a lot more resolution to be able to find, the level that you need to set as your standard for your soybean meal. In terms of amino acid supplementation in soybean meal, this is a good paper. This paper is actually the main researchers are coming from Evanek Degussa. So this is a major amino acid manufacturer from Europe selling lots of D-L-methionine. So keep that in mind. Recommended use in fish and shrimp feeds. There is so much out there that I'm really going to have to leave that for a separate paper and go through one species after another and give you what is recommended. So it's just too much to add on to the end of this one. Likewise, talking about fish meal substitution, which soy, of course, is a very important thing. This also deserves its own video, and I have a good one that I'll be doing very shortly. So there we are, Fish Nutrition Expert. Please subscribe to my channel, my YouTube. You can find me on LinkedIn. You can find me on X. Then please like, comment, turn on the notifications for any of the places where you have found my work. And most of all, I really would like to encourage you to share this, particularly if you were a student, to share it with other students who are also looking for information about using soy in aqua feeds.